Hi, my name is Isa Haani Long, and this is my final project for AP Statistics. So the question that I decided to choose was, do males get a higher SAT score than females? So this is my introduction slide. As you can see, here's the question, as well as the name of the group members, and it's just me. As for the data collection, to randomly select, I decided to collect students from Tinian Junior Senior High School, and I was able to configure around 63 people at our high school who have already taken the test. I ended up choosing 28 of those individuals, and they were randomly selected out of a hat, those names, 28. So after picking out 28 names, 15 of the names that I picked ended up being boys, and 13 were girls. And then I ended up separating my data into two groups, which is group 1, which is 15 males, and then group 2, which was 13 females. Here's my table of values. So as you can see, here were the 15 male scores and the 13 female scores. All the scores that they self-reported to me. Next, I will be showing my histograms of both of the group sets. So this is group 1, the male SAT scores. Here you can see whether it's unimodal or whatnot. I did the same thing for the female SAT scores. Next is my hypothesis and alpha level. So HO, the average SAT scores of females, is the same as the average SAT score of the males. And the alternative hypotheses would be that there is a difference between the two, between the average SAT scores of females and the average SAT scores of males. So as you can see, here is my actual hypothesis. The first one represents the HO, and then the second one, the alternative hypothesis. And then I ended up using 0.05 as my alpha level, and I explained a bit more as to why I chose it in my project planning. So here next is my conditions. So for the random condition, the same thing as how I collected my data, I explained how it was randomized. For the 10% condition, the sample size of 15 boys for group 1 is less than 10% of all boys in the world, and the sample size for 13 girls, sorry, I meant to put 13, in group 2 is less than 10% of all girls, student population-wise. So the nearly normal condition, as seen in the histograms above, both appear to be, somewhat unimodal and symmetric, so that's why they're nearly normal. For the independent condition, boys and girls are considered independent groups. So next, to state the test name, because the conditions are satisfied, it is appropriate to model the sampling distribution of the difference in the means with a t-model, and we will perform a 2-sample t-test. Here is my statistics and mechanics. So for the number of individuals in group 1, as you can see, it's 15, the mean is 1246, and the standard deviation ended up being 128.11. I did the same thing for group 2, so the number of students was 13. For the females, the mean ended up being 1320, and the standard deviation ended up being 141.42. In the mechanics and statistics picture that I included, you can see the t-score formula, me inputting it, and then that ended up being my t-score value. For the degrees of freedom, I ended up going with the smallest number of groups when you subtract it by 1, so that equal to 12, and I used the number of group 2 as it was the smallest out of the two. Then I ended up drawing out the t-score, and then as you can see, I calculated my p-value, and it ended up being over my alpha level score, so it was 0.174889. So to conclude, the calculated p-value is greater than our significance level, which means that we will fail to reject the null hypothesis, meaning that there is sufficient evidence to suggest that there is no difference in the average SAT scores between males and females. So here are some working pictures in hopes of getting extra credit. These are some of the students that I surveyed. There were a lot more, but these were just some of the 2 that were with me at the time. And then you can see the other picture, which is me basically inputting the data. And yes, thank you so much for listening. Bye-bye.